Hello everyone, today we're going to be working on fundamental problem 6.11, and this problem is saying to determine the force in members GF, GD, and CD of the truss and to state if the members are in tension or compression. To take that P1 is equal to 22 kilonewtons, P2 55 kilonewtons, and P3 55 kilonewtons. So to start off this problem, what I'm going to do is I'm going to first determine where the cut will go through the truss. And usually what you want to do is you want to make sure that your cut goes through all the members that you are trying to determine their force. So in this case, we have to determine the force of GF, GD, and CD, which is why we're going to do the cut then right here. That way it goes in between all of these three members. So when doing the cut right here, we now have two parts of the truss, the right side and the left side. So the next step would be now analyzing which side of the truss would be easier to work with. If we take a look at our left side, we have two known forces, and then from there we have this support, which is a pin support, meaning we're going to have two reactions, 1 and 2, our vertical and horizontal reaction, and they're unknown, so we would have to first solve for the values of the reactions and then proceed using the method of sections to determine the forces of these members. Meanwhile, if we look at the right side of the truss, we just have one known force, and since we have a roller support right here, we would just have one unknown reaction, our vertical reaction. So in a way, looking at both sides, in my opinion, it would be easier to work on with the right side of the truss as compared to the left side with the truss. So that's what I'm going to do. So my first step before using method of sections to determine the forces of the members, I'm going to determine the value of that reaction. So we know that since it's a roller support, it has to be a vertical support. I'm going to assume that it is going upwards. We're going to call it E sub y. So to determine the value of E sub y, what I'm going to do is I'm going to take the sum of the moments about point A. That way, these two reactions at point A will not be creating a moment, and I would simply just be solving for the value of E sub y. So that's the first thing that I'm going to do. The sum of the moments about point A have to equal 0. Our piece of 1 has a force of 22 kilonewtons and a distance of 2 meters. From there, we know it's going to be creating a clockwise moment, so a negative moment. So a negative moment of the force 22 kilonewtons times a distance of 2 meters. From there, we will have again a negative moment from our piece of 2 with a value of 55 kilonewtons and a distance of 4 meters. From there, once again, a negative moment by our force piece of 3 with a value of 33 kilonewtons and a distance of 6 meters. And then from there, we have our E sub y. Our E sub y will be creating a counterclockwise moment. So that's a positive moment with a force. That's what we're trying to determine times the distance of 8 meters. And all of that has to equal 0. From there, we would get something like 8 E sub y is equal to 462 kilonewton meters. And from here, we would just solve for our reaction E sub y, giving us a value of 58 kilonewtons. Since we got a positive number, that means that we assumed correctly the direction of our reaction, meaning that it will be going upwards. So now that we have that, we can now proceed to solve to using the method of sections to determine the value or the forces of each of these members. So I'm quickly gonna erase this a bit, move it just a bit here. So I'm gonna assume that all of my members right now are in tension, so away from the joints, but we will find out if this is correct or incorrect. So my arrows are going to be going away from the joints since I'm assuming that they are in tension, not in compression. So from there, what I'm going to do is you could draw now the right side of the truss, but I'm simply just going to be working with the figure. So from here, what you want to do is you usually want to take the sum of the moments about a point where two members meet and where those two members will not be creating a moment. So you could be solving for the third member. So right now, I'm going to be taking the sum of the moments about point D right here. Right here. That way the force CD and the force GD will not be creating a moment, and then the force of the member GF will be creating a moment, so we'll be able to determine the value. So taking the sum of the moments about point D has to equal 0. So as you guys could see, our force of the member GF is to an angle, so we have to determine some geometry right here. So we know right here, it's given to us that from here to here, there is a length of 1 meter, which is basically from G to F. So we know that if we were to go vertical up, we have a span of 1 meter. Now, if from G to F, we know there's a distance of 2 meters. So that means that we have 2 meters right here. And then from there, as you guys could see, our bar is the hypotenuse side of that triangle. So if we were to use the Pythagorean theorem, doing a squared plus b squared is equal to c squared, we would end up getting that this side right here has a value of the square root of 5. So with using that, we'll be able to determine to de to be able to determine the force of our member GF. So now looking at this, since we're taking the sum of the moments about point D, what I'm going to be doing is I'm going to be doing the horizontal component. So the force that's going in either right or left direction. Since I am assuming that it is in tension, my force is slanted to the left, so my horizontal component of it would be going to the left, because if I were to deal with the vertical component, we know that it would also not be creating a moment about point D. So I'm going to be dealing with the horizontal component of it, so I'm going to be multiplying the force of GF by 2, since this is the horizontal component of the triangle, over the square root of 5. Okay, so since our force is going to the left, we know it's going to be creating that counterclockwise moment, meaning a positive moment. So we have a positive moment of our force. We said to get the horizontal component of it, we would have to be multiplying it by 2 over the square root of 5 times the force of GF times, so this is our force right here. And then from there, our distance, since it's the horizontal component, we know that from here to here, we have a distance of 2 meters, so times 2 meters. From there, at point D, we know that this member will not be creating a moment, this member will not be creating a moment, and our P3 will not be creating a moment. The only thing that's going to be creating a moment is our reaction. We know it's going to be creating that counterclockwise moment as well with a force of 58 kilonewtons with a distance of from E to D. We know there's a distance of 2 meters as well. So positive moment of a force of 58 kilonewtons times 2 meters, and all of that has to equal 0. So from there, we would simply solve for the force of the member GF. So we would end up getting 2 over the square root of 5 times the force of GF has to equal negative 57.75 kilonewtons. And then from there, we would simply just solve for the force of the member GF, and we would end up getting a value of negative 64.6 kilonewtons. And as you guys could see here, we got a negative number. That means that we assumed incorrectly, meaning that it will actually be in compression and not in tension. So now that we found one of the forces, now what I'm going to do is I'm going to be taking the sum of the moments about point G, because when taking the sum of the moments about point G, the member GD and GF right there, they join together, so they will not be creating a moment. So since they're not creating a moment about point G, those both of them, that way we would be able to solve for the force of the member CD. So that's what I'm going to do. So the sum of the moments about point G have to equal 0. We know that our force of the member GF will not be creating a moment. Our force of our member GD will not be creating a moment. So the only thing that's going to be creating a moment is our force, the force of our member CD, P3, and our reaction EY. So since I assumed that our member is in tension, in this case, it is going to the left, meaning it's going to be creating a clockwise moment, meaning a negative moment. From there, the distance is, we know that from here to here, we have a total distance of 3 meters. So we have a negative moment with a force, that's what we're trying to determine, force of CD times a distance of 3 meters. From there, we have our P3. Since it is going downwards, we know it's going to be creating also a clockwise moment. So meaning a negative moment with a force of 33 kilonewtons. And then from here to here, we know that there's a distance of 2 meters. So negative moment with a force of 33 kilonewtons times 2 meters. And then from there, we have our reaction E sub y. This is going to be creating that counterclockwise moment, so positive moment with a force of 58.58 kilonewtons with a distance of, from E to G, we know there's a distance of 4 meters. So plus 58 kilonewtons times 4 meters, and all of that has to equal 0. From here, we would simply just solve for the force of the member CD, and we would get a value of 55 kilonewtons. This number came out to be positive, so that means that we assumed correctly and that the member will be in tension. So from here, we have found two members. So now we just have to find the third one, which would be the member GD. Since GD is also at an angle, we know that we could either take the sum of the forces in the y or x direction because it has both a vertical and horizontal component. So what I'm going to do is I'm going to be taking the sum of the forces in the y direction to solve for uh, the value of GD. So this the sum of our forces in the y direction have to equal 0. So the first one would be our P3, which is 33 kilonewtons. It is going downwards, so that's negative 33 kilonewtons. And then our reaction E sub y, that's going upwards, so positive 58 kilonewtons. So negative 33 kilonewtons plus 58 kilonewtons. And then from there, we have our member GF, which has both a horizontal and vertical component. So that means that we will have to multiply the value that we found right here, our force G of F, by 1 over the square root of 5, since now we want to deal with the vertical component of that force. And since we assumed that it was going to be in tension, for us, it's going to be going upwards, so upwards. But don't worry, we know that it's actually in compression, but this negative sign will already deal with that, with that, with us guessing incorrectly. So we have a positive force of We said that it would be 1 over the square root of 5 since we're dealing with the vertical component of it, times the negative 64.6 kilonewtons. And then from there, we have our force GD, which is also to an angle. But since we're doing the sum of the forces in the y direction, we're going to be multiplying our force by, we know that this, the vertical side of this triangle, as you guys can see right here, where the hypotenuse is our member GD. So we know that this side of the triangle has a span of 3 meters. And we know that this side of the triangle has a span of 2 meters. So once again, with the Pythagorean theorem, we would end up getting that this side of the triangle has a span of the square root of 13. So we will be multiplying our force of GD by 3 over the square root of 13. And since I assume that it's going to be in tension, in this case, away from the joint is going upwards, so a positive force. So a positive force of 3 over the square root of 13 times the force of our member GD. And all of that has to equal 0. So from here, if we were to simplify it a bit, we would get 3 over the square root of 13 times the force of GD is equal to 4.14. And then from there, we would solve for the force of the member GD. We would end up getting a value of 4.98 kilonewtons. And since we got a positive number, that means that we assumed correctly and that this member will be in tension. And with that, we are done with our fundamental problem 6.11. So once again, the first thing that you want to do is you want to determine where that cut is going to go through your truss. You want that cut to cross or go through all the members that you're trying to determine their forces. From there, analyze your right and left section, which one would be easier to work with. Then determine the value of how many reactions, unknown reactions that you have. And then from there, use the method of sections to determine the forces of those members. Usually you want to take the sum of the moments about a point where two members meet, so that way you would be able to solve for the other member. Thank you guys so much for watching this video. If you guys found this video useful, please feel free to give this video a thumbs up. And if you guys would like to see more videos like this, please feel free to subscribe to our channel.